Hello, my name is Devarshi Vadia, and in this presentation, I will deliver the topic named as Concept of Designing of ARM. Let us see the out. Let us see the outlines of this session. That is, we first see the difference between RISC and CISC architecture. Then, what is ARM processor? Then, why ARM processor is required? Then, history and philosophy of ARM design. And then we compare the design philosophy of RISC and ARM. And at last, I will I will give you the. Let us start. First, the difference between RISC and CISC architecture. In CISC architecture, it is rich in instruction set, also complex instruction set. But in RISC, there is a simpler instruction set. In CISC, more addressing modes is there, but in RISC, the less addressing modes is available. In CISC, there are few general purpose registers, that is also called GPRS, and in RISC, there are large number of general purpose registers. Instruction set Instruction pipelining is complex in case of CISC, but instruction pipelining can be implemented easily or very easily in the RISC architecture. Instructions are having complex execution cycle depending on complexity in CISC architecture. And is in RISC architecture, most of the instructions are executed in a single cycle. CISC architecture is mostly suitable for general purpose applications, that is Intel x86 family processors, and RISC architecture is suitable for real-time application, and that examples are Atmel, PIC, and ARM. Let us go ahead. What is ARM? ARM is an abbreviation which is used for Advanced RISC Machine. First, RISC-based ARM is a first RISC-based microcontroller for commercial use. ARM ARM is a market leader for low power and cost sensitive embedded application. These two words, that is, these two words, low power and cost sensitive, this is highlighting word in the ARM. ARM was developed by Akron Computer Limited. This concept was introduced in 1980, and then after ARM is introduced, that is, ARM Limited was formed in 1983. ARM is not pure RISC architecture, but it also supports complex instruction set. Why ARM processor? Why ARM processor? This is very much important question. You have studied or you have heard about AVR families of microcontroller. In AVR family, the microchip are much popular chips in AVR family, and microchip PIC are much popular chips in the world of embedded systems. But many embedded system needs precise computing, precise computing, minimum power consumption, and high-speed computation with a smaller code size. Such features are not available. Such features are not available in 8-bit family of microcontroller. 32-bit ARM architecture has such features, which makes it suitable for applications like mobile phones, video games, robotics, image processing, speech processing, and adaptive control system. Now let us see the history and philosophy of ARM. This is the brief history of ARM core. Let us not go in deeper in this history. If you see, then you pause the video and you can see this. Let us let us see the nomenclature of ARM as the time limits. It's the I am not able to explain nomenclature of all ARM processors. That is why I have take example of one ARM processor, that is ARM7 TDMI, which is very famous. In this, the T stands for thumb mode, D stands for detect debug support, M for multiplier, that is extend, I for ICE, E stands for extend instruction, J for Jezal DBX, that is direct bytecode execution, F for float point, S for synthetic softcode. Now the ARM design philosophy. There are a number of physical features that have driven the ARM processor design. Low power consumption is is delivered by smallest core. Limited memory is given by high code density. Die density is given by simpler hardware execution unit in the ARM. ARM core is not pure RISC architecture because of constraints of its primary applications, that is the embedded system. And this is the obvious question. That is, ARM is a very simpler than RISC. But is it is it so? Simplicity favors regularity in the ARM processor. Yes, in this case, it was favors. This design that is written in this design rules allow the RISC processor to be simpler and the core can operate at high frequencies, high clock. Now, comparison of design philosophy of RISC. RISC as a reduced instruction, register bank, pipeline architecture, pipeline and load and store architecture. And the ARM has variable cycle execution, inline barrel shifter, thumb 16 instruction set, conditional execution, enhanced instruction. This is the reference www.arm.com. That is the official site for ARM. These two are the reference books that I have used. Last, thank you very much for watching this session.